Hello everyone and welcome to the Victoria Game Engine series. This is something that I've been cooking up doing for a few months, and I'm finally at the point where I believe I am ready to present this and sort of pitch the idea to you. So this is going to be a game engine we are writing in C++ and OpenGL, as the title card shows. Now, for some of you, you might be wondering what on earth a game engine is, and in short, it's a sort of an assembly tool for us to take individual parts that all make up games, whether that's textures, models, scripts, physics, dialogue options, whatever you can really imagine you'd need for a game, and package it all in one application so that we can then export it as one executable and for everyone on the whole planet to enjoy. Good examples of a game engine would include something like Unity or Godot or Unreal. If you're anything inclined towards the idea of a game engine, you've probably heard of those names before, and I don't really need to reiterate that point to you. But they are very good examples of what a fully fledged game engine will look like. It will take a long time for our engine to get anywhere near that point, but hopefully you guys will enjoy the tutorialized version of getting to this point, rather than dealing with a tool that's big and complicated and a lot harder for some people to understand. Another question that a lot of people may have is, why do we create our own engines if engines exist? Now, a lot of the time I've seen the opposite of the question, asking why on earth people want to use proprietary engines when they can create their own. But for our case, we're going to assume that you are asking the opposite of the question. In this case, it's mostly because we want to teach people for us to learn how to make something from scratch. We don't really have a need for a custom engine at this point. For you and me, it is a learning tool to learn how to not only learn C++, but how to create assets and compile things, and a very different way of doing things to how you may normally do. For some people, that may not always be the case. So you may want to create a feature that's very niche to an engine that you can't really have in a general engine, but you need it for your game, and you're willing to put the time and effort in to create your own engine that functions differently so that you can gain optimizations from that. That's perfectly fine. And again, you can also just have optimizations in a way, so you just have a game engine that is a smaller size, or a game engine that runs a lot faster. You can also code it for the simple example of wanting to learn a language. I mean, in this case, most people are here for a very similar reason. So while we're also talking about this, I also want to talk about why we choose C++. It's generally referred to as a lower level language, which means that it's closer to the operating system you use, rather than a higher level language, which is more platform agnostic. So something like Python, for instance, is generally a higher level language because it will run the same whether you're on Windows, Mac, Linux, whatever. It will do pretty much the same sort of job effectively. Which C doesn't do. C is lower level. You will have to write some of your C code very differently depending on what platform you're using. So because it's that lower level, it means that we can directly deal with certain APIs. So for instance, as I've said there, you can deal directly with our rendering APIs, those being DirectX, Vulkan, OpenGL. You can also directly deal with the memory, meaning that when we deallocate free memory, we are directly dealing more or less with the actual physical memory that you have in your computer. So it also benefits as it's a superset of C. It's not necessarily a different language. A lot of things that existed in C exist in C++, but there are more features that exist in C++ because it has new things. There are also things that are not existent, but those are fairly minimal, and I don't believe in the grand scheme of things moving from C to C++ has that many removals as much as it has far, far more improvements or additions. So those features that we have really benefit creating an engine because it allows us to use more agnostic ways of doing things. It allows us to do things slightly smarter, and therefore create things more optimally and make things a lot easier for us. With all that said and done, I do want to talk a little bit about our design goals. By design goals, I basically mean what we want to be doing to create this engine. So the first thing we want is a fully functional 3D renderer. What that means is all of the functions that we would expect the renderer to do are present. There is potential for extra renderers such as Vulkan and Direct 3D support in the future once OpenGL is fully functional, as I've said there. But we will be starting with OpenGL, and we will be using OpenGL for the foreseeable future once we're at a point where we are happy with it. Implementing Direct 3D is probably not going to take as long as it will to take Vulkan, but I think since Vulkan's more widely used and going to be more relevant to the more platforms, it's probably better to look at that. We may also have to look at something like Molten VK or Volk, but that's Mac OS, and again, I can't really develop much on Mac OS because I don't have a Mac, and I'll talk about that in a little bit. So the other thing that we'll want to do is we also want to have the ability to write custom code. What that means is that we are going to want a way for people to interface with the things we're doing rather than it just being able to plop a massive object and apply some textures to it. We need to be able to make people, or we need ways for people to do things with the engine. So I've got some ideas of languages we use. I've got VScript in air quotes there. That would be sort of a sister language to GDScript. It would be like similar. It's designed to be used specifically for like Victoria Engine. It's not designed to be used as a language that you can use pretty much anywhere. It's designed specifically for that purpose. We could also use C# as well. C# would require a similar amount of work to do. You would be using a separate IDE for that. You would have to pre-compile it through something like MS Build, but again, we will probably be getting to that later on in the series because custom code is something that will take a long time to do, but I do sort of want to touch on it fairly early on rather than spending ages and ages and ages and ages waiting for it and then approaching it really, really late in the series, because I believe that it's something that I want to take the challenge on and I want a lot of people to learn from so that they can adapt that for their own solutions. We also want some custom maths and physics libraries. What I mean by that is I want to be able to, for the entire engine to use its own made maths functions and its own made physics functions. Those will probably be bouncing off one another. So when we're doing the maths library, we'll probably do a first iteration of that. Then we go to physics. We'll have to do maybe some updates or improvements in the maths library. And those sorts of things will just have to happen as it goes on. The other thing we want is good documentation. So by that, I mean that over the course of the entire engine, I'm going to make sure that we have appropriate amount of comments. We have maybe a wiki that you can check. There's documentation on pretty much every function that you'll need to understand. Everything you can basically either look at a website or look directly in the code and understand what's going on. I would prefer to do the former because the latter will be a lot harder for people, but I mean, especially if you're maybe not that technically minded and just want to know what a function does. Again, we'll probably be getting onto stuff like that once we've got a bit more of a setup done. With all that said and done, we also want to talk about the build layout. This one is very similar to Godot's build layout because after looking through several ways of doing it, I figured that this one was actually going to be the easiest to export games from. So the way it's going to work is we're just going to have one exe file that functions as both the editor and the game. If you want a project manager like Godot, we can do that as well, but I am thinking of making the project manager potentially separate or just loading the project differently. So we will talk about that at a later date. The main reason we do this is, again, users shouldn't really need to have a bunch of C++ code that they need to then compile so that they can make their own game. I don't want to burden someone trying to install the engine with 1,000,001 DLLs and exe files and static libraries and a bunch of junk that looks like a mess to try and clean up when you uninstall an editor. So I just want to make sure that the build is small and clean, sort of emulating a bit more elegance in how we want to make things here. So with that sort of build style briefly gone over, I also want to talk about how to use the series as a guide to learning C++. I want to make the series approachable for most people who either want to learn C++ or want to learn how to make an engine. Because of that, it means that the videos are going to be structured a little bit differently to how you may expect. I'm going to spend a bit more time talking about the theory behind things and why we would do things. which means that videos at first will be a lot longer because I'll be trying to explain each sort of individual step. Now, a little bit later on, I will mention the absolute basics I want people to have. Like, I feel like going into this without knowing some at least raw basics of programming is probably not a good idea, so I'll talk about that in a sec. But again, we want to make sure that people have a better grasp of the concepts. It's more a tutorial on the language and design theory rather than a tutorial on just making an engine by copy and pasting code. So with that said, I also want to talk about the series layout. In order to make it more readable or to make it easier to reference things, I'm going to do 5 episodes of new content that will be either continuing a feature we're doing, creating new things for the engine, assets, pretty much anything that would go under something that you would classify as new or improving. And then we want to follow that up with, at the very least, 1 episode of refactoring and improvement, as I've said there. Broadly speaking, that just means that we're going to have basically like, I don't know, an episode 5.1 that's going to just talk about the little change that I want to make because maybe a feature I added is now applicable somewhere else, or that a feature, or that the code that we've used isn't optimized and I need to change it to make it more optimized, and so on and so forth. In order to track every episode and every feature that we put, there will be a GitHub repository that I will link down in the description. Hopefully I remember to post it publicly before I do that. If I don't, please scream at me in the comments. So there will be a GitHub repository, and that will have a comment every video, and it will lay it out as I've shown there. I won't really talk about that, but the way I'm also going to make the non-episode comments work is, if you see a comment that doesn't have that exact same title, that is probably either me updating the README, me updating a change log, changing something on the GitHub page, changing something in a README that exists in the files, updating, I don't know, some wiki or something. I'll try to keep all of the changes that are not relevant to someone watching a video off the channel, but I will make sure that all the relevant content is up there for you. And these will be direct references for every video. I'll make sure that every change I do in a comment is shown directly there, and therefore that I'm not missing anything in the certain comment. And if there is something I missed, then it should be on the repository for everyone to see. Pull requests, such as major refactor. So going back to that idea of refactoring, if there's only 1 or 2 episodes, or maybe even just 1 episode where we just like change a few variable names in a function so that it's more consistent, those will just be bundled as that's episode 5.1 changed some names. But if we're doing a larger refactor, maybe it takes, 6 or 7 videos to do in total, we will be making a whole pull request for it so that you can reference each individual step and also see how things change. In those time in pull requests, I will try to do my absolute best to make sure that I don't make any changes to main at the same time. And that's just so that the code is more linear in a path. And I'm not referencing 5 different episode like 5.1, 5.2, 5.3 in the comment list. So you can just see the whole comment and each individual in a more neater format. So that's how I'm going to be using pull requests. Finally, I'll just talk quickly about the short-term roadmap. So we're going to be starting out with some setup. Obviously, we need our build system created. We need all of our prerequisites downloaded and set up properly so that they all work. So that we're going to be using Windows and Linux as our starting items. So we will not be supporting Mac. And that's simply, again, as I said earlier, I don't have a Mac. I can't really make code specific for Mac unless someone else wants to do that for me. That would be honestly amazing, and I'd really appreciate that. But until I have an actual Mac, I will not be able to create any Mac OS specific code. So once we've got setup out of the way, we're going to move on to logging and error handling. Well, that logging is going to basically rely a lot on, or error handling is going to rely a lot on the logging, and logging is going to be dealt with slightly differently because errors, I want to make it so that errors can be sort of referenced, but don't always crash the application. There will be points where we need fatal errors, but for the most part, I'm hoping that we can at least make like errors not always break our systems. And error types, we'll get into that in the whole video, they will be a lot more robust than you may see in other series. From there, we'll also go to the custom variable type. So the variable type will be sort of a type that we use for pretty much every kind of data we can hold. So if you're used to the variant type in Godot, it'll be very similar to that. So we'll be able to store our integers, our strings, our floats, dictionaries, arrays. They will all fit into that variable type and will be held in a specific way. And there'll be a lot of work we can do with the variable type. We'll be enhancing it as we move on through the series when I come up with ways to do certain things. But for the most part, that will just be setting up that type as one whole video. From there, we'll move to the memory system. The reason I'm doing the memory system earlier than other series may do it is because memory is very important to the application, and I think it's probably the best just to have the memory set up in the first place so that we don't have to go back and refactor some code and potentially miss a standard library inclusion when we really shouldn't. Once we're done with memory, we'll move on to the vectors and arrays. Vectors and arrays they're two different things. They will function very similar to another, but they will also have different ways of doing things. So again, we'll get into that once we get to that point. From there, we will move on to the event system. Events will be very important for a lot of the input stuff we do, a lot of the OS stuff we'll do. They'll be important in the render as well. So it's very important to get this system stood up and stood up well. And from there, we'll also move on to the platform/OS layer where we actually create our first windows. We set up some of our backend to start using OpenGL code, and we'll also talk about making sure that things that change across languages, such as our current working directory and paths, work properly. So those sorts of things that we'll need to do at that point. Once we're done with all of that, we'll be very much ready to begin the renderer, and we'll probably be starting out with just trying to draw a very simple triangle, but making sure it's highly configurable in the first place. With all that said, that's pretty much the roadmap out of the way. Now, the last thing we want to do just before I wrap up is talk about the prerequisites. Maybe something that should have been earlier in the video, but I think is probably just best to put at the end of it. So the first thing we're going to be doing is we're using Clang as our compiler. Simple reason for this is because I, A, prefer it, and B, it's really flipping fast. It'll be useful. We will make other build systems as well. I imagine that implementing GCC, or because we're compiling for C++, G++, shouldn't be too tricky to set up, but there will be certain things I have to do there. Then we'll also need OpenGL version 3.3 on your system. Hopefully you have that. I really can't imagine that you wouldn't, but again, that would just be something we might support lower than 3.3, but again, that completely depends on what we want to do. So Glad will be our OpenGL extension loader. I will get into that a lot more detail when we get to explaining why it's important to have, but eventually we will remove it in the future, probably so that we can create our own implementation, because I am not entirely certain if we need a similar system for Vulkan. And the last thing that you'll need, which might sound really ridiculous once we've said all of those, is just a basic understanding of programming concepts. If you really don't get what a variable is, or what a conditional is, for while loops or functions, then I really recommend just having a quick look up on those, because they should be fairly easy to understand. They're not the most out there things to understand, and I think they're fairly easy for the average person to understand. So hopefully you get those. And with that all said and done, I will see you guys in episode 1. I'll just say out there, I don't have a strict schedule for these videos. Hopefully we're doing twice a week for the first couple weeks. Then I can move on to maybe once a week, or maybe once every 2 weeks. For those who have watched all the way and, still watch my other content, I do still want to make more of that content. But at the moment, this is something I'm really excited to get into. and I really want to, get out there. But with all that said and done, I really do hope you enjoyed this little overview video, and I will see you guys in the episode 1, which should be releasing around the same time. I'm hoping for the same time release time, just so that you can get a kickstart already. So I will see you guys then.